In this video, we will be learning about the loaders and linkers. So, till now we have learned about the assemblers, in which the source program that is written in the assembly language will be translated to some object program which is in the machine language form and will be used for execution. So, this conversion, it will be done by the assemblers. So, before execution, these object code need to be loaded to the memory to start its execution. So, for that purpose, we make use of this loader. So, loader, it helps in performing mainly the three functions like loading, relocation and linking. So, loading is like it brings the object program to the memory. That is, some allocation will be done for the object program so that it can start its execution. And relocation, it helps in modifying the object program that is located at any address that is different from the location originally specified. So based on the address, it helps in modifying the object program. Then linking, it combines the two or more separate object programs, supplies the information needed to allow cross references between those object programs. These are the main processes that is being done in order to execute any object program. So, loader and linker, it may be considered as a single system program. Together, we can, that is a loader, it will be performing both these operations together. So, loader basic function is like it performs the loading function and it helps in loading the object program into the memory so that it can begin its execution. So there are different types of loader in which we will be discussing about the absolute loader, bootstrap loader, relocating loader and the linking loader. So we are starting with the absolute loader, in which this is a simple loader in which no specific locations is mentioned for the object code to be loaded into the memory. So by the end, the loader, it will be jumping to some specified address so that it can begin its execution. So in this case, no linking and relocation will be done. Just it will be jumping to some location. It executes the program that is loaded in that, starting from that location. The records in the object program, it can be represented like a header record, text record and end record, in which loader, it makes use of the header record to check the name of the program, starting address and the length that is available in the memory. Then text record, it brings the object program contained in the text record to some particular address. You will be having some instructions in the text record and you will be having a starting address for each text record. So based on that address, it brings the object program to the address or the instructions to the specified address. Then end record is like once it reaches to the end record, it means that all the object program that is the instructions, it is being loaded to the memory in the specified locations. Now it needs to begin its execution. So end record will be having one address or label in which the control should go. So the loader, it helps in jumping to that address and transfer the control so that it can begin its execution. So this is the structure of any object program that need to be loaded to the memory with header, text and end record. So the object program, how it will be loaded to the memory, it will be, text record will be having one address, that is 1000, and based on this address, In memory also, in that 1000 address, the first text record will be placed. Similarly, it continues till this value. That is till this 0003, it will be continuing its value. Then another text record, it will be starting from 2039. So the next text record, it will be starting from 2039. So from this location till that 2039 memory location, no text record will be loaded. It is left as nothing will be there in that memory. So the remaining text records based on the memory, it will be loaded to the memory. Then algorithm for the absolute loader will be like, first header record will be read. It verifies the program name and length of the record. It reads the first text record, and if the record type is not equal to end record, do begin. What it does, if the object code is in any character form, convert it into the internal representation. So if it is in any character form, it will be converted to its machine form, either in the hexadecimal form. Then move object code into specified location in the memory. So once it is converted to its internal representation, move the object code to a location that is specified in the text record. Then read the next object program record. Like that, it goes on till it reaches the end record. Once end record is reached, jump to the address specified in the end record, and this is the task of the absolute loader. So most machines, they store object codes in their binary format. So this lessens the space and loading time, but it is not good for reading. Machine representation will be in the form of binary form in most of the machines. The object codes will be stored in their binary form, which takes less space and loading time, but it is not good for reading. Then so the representations of object code will be like either in the character form or in the binary form. So the character form will be like each byte of assembly code you will be represented using the hexadecimal representation, that is in the character form. Character form will be like, it will be given in the hexadecimal representation, which is easy to be read by the humans. Binary form is like each byte of object code will be stored as a single byte. It will be stored in the form of a single byte, and most machine store their object programs in the form of binary form. Then next is the another alternative form of loader called as the bootstrap loader, in which it is an example, it can be treated as an example for this absolute loader. Some modification will be given, and it can be treated as a simple absolute loader, which is the bootstrap loader. When a computer is first turned on or restarted, a special type of absolute loader, that is the bootstrap loader, it first loads the first program to be run into the memory. So usually this process will be done by the operating system. So the SICK bootstrap loader will be like, it begins at the address 0. Bootstrap loader, it will be beginning at the address 0. So it loads what it does, it loads the operating system starting at 80. It loads the operating system, which is treated to be as the F1 device, to the starting address 80. No header record or control information is there. Object code is consecutive bytes of memory. After loading the operating system, control will be transferred to the instruction at the address 80. Once the information from the OS is loaded, the control will be given to the 80 instruction at the address 80, so that it can start its execution. So the algorithm for SICK-XC bootstrap loader will be like, first X will be assigned as an address 0x80, that is to the memory in which the it need to be loaded. Then loop until the end of input, that is you need to get some character and convert from the ASCII character code to the hexadecimal digit. Okay, some character you will be getting using the routine getC and save that value in the higher order 4-bit of S. So an S register will be used, in which the character that is obtained first will be stored in the higher order 4 bits of the S. Then again using the getC, the character will be taken and combine the value to form one byte, like A plus S. That is using the getC subroutine, you will be getting the characters 2 times and combine them to form a 1 byte. First character that you will be getting will be loaded in the higher order 4 bits, and then second character in the lower order 4 bit. Then this value that is stored in A will be moved to the address that is stored in capital X, that is X register. So X will be incremented by 1. This is the algorithm. So getC algorithm, as I've said, getC is a routine which executes the following. It will be reading one character from the device F1. F1 will be the device. From the device, one character will be read. And if A is equal to 0x04, then jump to 0x80. That is, once it has taken the values, then that is 1 byte. If it has reached, means it need to jump to the address 0x80, starting address of the memory that need to be executed. Else what it does, checks whether A value is less than 48. So less than 48 means you will be getting some character. That is, if you are taking the value from the F1, means you will be getting one character and you will be checking whether it is less than 48. So if so, means it goes to the getC routine, so that it will be taking the next value. And again, it will check whether the value is, then go to getC. Then it checks that what it does, it will be converting the value like into its representation, like A minus 48 to its hexadecimal form. If A is less than 10, then return A is equal to A minus 7. A is equal to A minus 7 and then return. So this helps in what it does, it will be doing some conversion and will be loaded to the register A. So this getC routine, at a time one bit will be, at a time one character will be obtained from the F1 device, and it converts from the ASCII character code to some hexadecimal format using these statements. So the ASCII value of 0 to 9 will be like 0x30 to 39. The ASCII value of A to F will be 0 to 41, 0x41 to 46. It takes the value. So in order to convert from ASCII character to hexadecimal, these operations